Okay, let's talk about the part of power supply next. Everyone reviewed the signal sent by the south bridge of the trigger circuit that we analyzed before. After triggering, it sends out PCH. It sends out S5, S4, S3 respectively. These signals are not only sent to EC, but also to other ICs. For example, there is S5 first, and then S5 comes out 3.3 volt to the EC at the same time. S5 will also notify other signals to generate other signals to power the IC to work. S4 will also control part of the power supply IC to work. Which IC is it? This part is also more detailed, and it is easier to break. Later, power supply circuit must rely on memory power supply, lightning power supply, and interface power supply. They are all controlled by S5 and S4 signals. Therefore, if each power supply IC does not work, in turn check how the intermediate related circuits of this signal are generated. Next, we talk about where the S5 signal goes at first. So we talked about the trigger circuit, mentioned S5, S4, S3. The first to come out is the power supply controlled by S5. We must first check S5 part when repairing the power supply circuit. Then look at S5. It is sent to the EC all the way. Another circuit through the RA115 resistor. The signal S4 PWR EN was generated. Through this picture we can see it is 3.3 volt after this 0 ohm resistor. It is an insurance resistor. We also mentioned it in the basic course. This insurance resistor can be short-circuited in the maintenance. We use a multimeter bar to measure it. The sound is good. If there is no buzzing sound, it is bad. Then it comes from 3.3 volt and then goes through the 3.3 volt. Because it doesn't reduce voltage, it plays an insurance role. Convert to S4 PWR EN. It passes through an ordinary 100 ohm resistor of RA114 to limit the current. Change to USB PWR EN signal 3.3 volt to control the power supply of the power supply circuit in USB interface. The power supply of the USB interface can be seen from this drawing. It is the first to work. So in maintenance, if we test our S5, this light does not come out. Then we have to check whether these related components are damaged. And then we'll hold them again. This is a workflow of the PWM SLP S5. Okay, let's talk about the second signal. Wake up signal, enabling signal, SLP S4. It was generated after S5 by South Bridge. It was sent to EC all the way, and they also sent 3 circuit lights to other circuits. So let's talk about this circuit first. Then it passes through U4A10 on the first circuit line. It can be seen from this IC that is a voice circuit. U4A10 generates a 3.3 volt TPAD USB, these 2 signals. Use these 2 signals to control power supply circuit of touch panel board. Our MacBook Touchpad also needs power supply. Its power supply IC relies on our signal to control it. If this pad was damaged, our touchpad is unusable or malfunctioning. This power supply is controlled by, this is the first way. It is generated in 2 circuits, passing through U4A10, so the touchpad will not be available in the future from the hardware. It has something to do with the laptop system and driver. If the software is excluded, the touchpad still cannot be used. You need to check whether this line is damaged. Then after the first circuit line is generated, it becomes the second line immediately after SLP S4. After work to complete, everyone look at this drawing. PM SLP S4, 3.3 volt after RA179. But we repaired it by model Mac A1466. As for other models, you can refer to it to repair. The principle is the same, but the numbers are different. We also mentioned this in the last class. Don't learn things too rigidly. This point must be clear. So this is the first 0 ohm resistor, RA179, and the second resistor, RA175. These 2 resistors generate signal to the standby IC. Let the standby IC control the 5V upper and lower tubes to generate 5V large inductor power supply. We mentioned it in the last class and also mentioned it in the previous class, where MacBook 3V 5V large inductor are on standby. 3.3V large inductor is working with electricity. 5V large inductor works after triggering. It's reflected here. After this standby IC resistor 3.3V, only then it can control the upper lower tube to generate voltage of 5V large inductor. So if the 5V large inductor does not change after triggering, then follow this slide circuit road to repair. This is the second circuit of SLPS4, which power supply circuit does not signal generated by it go to. So what does SLPS4 in step 3 looks like? Next, let's take a look at which power supplies it handles. Okay, where the third signal of PM SLPS4 reaches. Look at this picture. It is converted into a 3 switching signal through 3 resistors. The first resistor is RE111 20 kilo. It is to 3.3V memory power supply IC. There is this pin in the power supply IC of the memory. When repairing the power supply circuit inside the memory, we will talk about this source of the signal. After memory power supply IC resists this, the IC starts to work. Control the power supply of the memory. The upper and lower tube generate the power supply of the memory. In other words, this S4 is also very important. The third output is critical. Then look at the other two, I116. It is sent to the 1.8V through a 0 ohm resistor. At the same time, it will also go to certain power supply IC. Then it is divided into 3 channels to output. It can be seen that the output of S5 is obviously different from the output of S4. Different power supply just to control. When we are repairing, we need to check this 20 kilo resistor. If memory is not powered, check that the upper and lower tubes, including the IC, are not working. At this time, we have to trace the resistor to see if it is damaged, or see if there is any problem with the S4 itself. If this side is 3.3V, this side becomes 0V. There is only one case. The resistor was dropped or the internal wire was broken. It can also be measured through the pin of the IC. Checking the resistance value can also measure whether the intermediate circuit is open. It's the same with these 2 power supplies. These 2 power supply, it is also time to rest. If the memory has power supply, so it's 2 power supply situation whether there is a power supply. Basically, the S4 part has been repaired. That is the power supply part. We will talk about how this major power supply IC work and how to fix them later. Our main purpose today is to talk about the logical relationship between S4, S5, and S3 to control what things. We have to understand this point clearly. S4 is divided into 3 circuit rows from this point. This is the knowledge point of S4. Okay, let's take a look at our third signal, the switch signal. PM SLP S3L, it comes out after S4, and the last one comes out. Then it will pass UA1AO when it is given to EC. The one in front pass through a 100 ohm resistor, RA17A. It is 3.3V. It was sent first and then changed to PM SLP S3BUFL. It is used as a switch signal. Then I hope everyone can look at the picture. It actually sends this to IC all the way. U3210 we call Raiden IC. It and the power IC of U7A70 bridge are both used as a 3.3V in the switching signal. When we learn power supply circuits, we must talk about how this circuit IC works. After we resist such a switch signal, this IC can work. Send power to its corresponding load. Then the first circuit row has to be sent here. Everyone, take a look at this first circuit row and send them to these 2 ICs. Everyone, look at the second circuit row. It passes RA1A7 with a 3.3V. Generate P5V as its switch signal and let the power supply IC start working. Specifically, who is the power supply IC for? At this time, we should not pursue this. So we had to investigate the latter circuit and find out which device the IC supplying power to via master ring timing problem, which means that the order of its word must be clarified. This is not what we care about. It is mainly related to which equipment this circuit supply power. This is second circuit road, is switch signal. This one is resistor of RA17A. Another see the third circuit road. Here is the third circuit road. After the 0 ohm resistor of RA185, it generates P3VSO-EN again, sends it to the UA030 power supply IC. This power supply IC starts to work again, powering its load. The working principles of this circuit are the same. It's the same as long as we fix any one. But it must be repaired until the MacBook can trigger the screen not to turn on. At this time, we have to find out these power supply ICs. As long as there is an abnormal power supply, it may cause our Mac not to turn on and trigger the screen not to turn on. This is the third circuit row, and the fourth circuit row is P1V05SO. It passes through RA185, which are all 0 ohm resistors. Then it is also a 3.3 volt used for its switch signal. At this time, this IC only starts to work after receiving this switch signal. So F3 plays a very important role in this. Any damage to it will cause the corresponding IC to not work. Our MacBooks, their design in this area is relatively complete. The same is true when we are overhauling. This is S4, S5, S3. Where did these three signals go? We all have to check. Okay, let's talk about it next. Then we just talked about after the trigger. S5, S4, S3 control the major power supply. So in this issue, we first talk about how the memory power supply works. The memory power supply after this is triggered, it is still a more significant power supply. What does memory power supply consist of? Everyone take a look at this circuit diagram. Here we zoom in. First of all, it has a precision resistor R7350, which is mainly used to detect current. It is also easy to broken in maintenance, but it cannot be short-circuited. It is used to detect current. Everyone sees this error of 1%. It cannot be changed casually. Only MacBook has this kind of precision resistor in the circuit. Generally, our Windows computer don't have this resistor. The second one is our inductor. Everyone sees L7330. This is a large inductor for memory power supply. This inductor is not easy to break. It plays a role of energy storage and filtering here. If there is a normal voltage on the inductor in repairing, it means that the circuit is okay. Its voltage depends on the generation of memory. Our memory is divided into generation 2, generation 3, generation 4. Including the early 1 generation. Our 3rd generation is generally 1.5 volt, the 4th generation is 1.2 volt. In general, the relatively new technology is 1.2 volt more. Take a look at the main power supply of memory here. The English symbol for this work is here. The English name of the main power supply for the memory is PPDDR-S3REG. Let's go back again. This is a power supply upper and lower tubes. Q7330 and Q7335. Q7335 is the lower tube, Q7330 is the upper tube. The Q7330 inductor, it comes in from a common point, generally between about 8.6 volt and 9 volt. When switch is not pressed, the public point has already sent the electricity first and put it here first. This tube is not working. You see the 4 pin of the GPOS power supply IC connected to the memory. The power supply IC of memory is in this position. Let's zoom in. Q7300 is the main power supply IC of the memory, which is also relatively easy to break. After it is triggered, it needs to output a square wave to the GPO of the upper tube. Then the GPO of the lower tube also outputs a square wave at the pin 11 of the DRVL. The two tubes are turned on in turn. When we talked about the 3V, 5V, we also talked about it. This working principle is called the switching power supply. That is to say, after triggering, the IC will send a square wave to control the upper and lower tubes to turn on in turn. Charge and discharge inductor so that the inductor generates a voltage of 1.2 volts for memory use. So if this IC wants to work, then it also needs working conditions. It is also the first to work after the trigger is powered. Then this IC also needs 2V power supply. Let's take a look. First, the first power supply usually is 5V. After triggering, the second power supply, this is 5V in. So if it is being repaired, if there is electricity on this capacitor, what does it mean? If there is no problem with the power supply, then look for its upper level component. The same as the first power supply, we can also measure the C7300 capacitor. This capacitor is easy to break. If you measure this capacitor in maintenance, use a buzzer to measure both ends. It sounds you can just pull it off and not install it. It is possible that the short circuit of the capacitor may cause the voltage to be abnormal. We measure the power supply in maintenance. Generally, we measure the capacitor. With this power supply IC, it still can work. If there is this voltage, then it also needs a switch signal. Where is its main switch signal? Everyone look at the switch signal of our S5 pin. This pin is its switch signal. It is 3.3V. It is a DDR-REGN sent from a soft bridge after triggering. Send it from soft bridge, just go through the middle circuit row. We talked about it in the last class. S5, S4, S3 signal sent from one of them. If you want to know where it came from, we can click on this signal to select. Copy this into dialog box. It should be 3.3V. Let's search. Look at this position. PMSLPS4 was mentioned in the last class. Just come out this circuit road. Let's mark it again. Go down this circuit row and go out to 3.3V. So during maintenance, if there is no 3.3V on this circuit road, when this resistor PMSLPS4 is triggered, it is sent by the soft bridge. So this signal is also a very critical signal. We should pay attention to it when we check. So let us think in reverse. How did this switch signal come about? It doesn't work even with the switch signal. It's just a second condition of the IC. Two set screw power supplies, one switch, and it also generates an 1.8V REF reference voltage out. Out from our 6 pin. I usually measure less on this circuit row. I'm testing power supply and switching signal a little bit more. After we resist this signal, it is a third circuit road. The first power supply VBST is called self-excited power supply. Receive self-excited power supply generated by the boost capacitor. Looking at it and the other way around, it is a VBST pin, and it will be connected to a boost capacitor, past a zero circuit road resistor R7325. Rely on this boost capacitor 67325 IC to output square wave to control the charging and discharging of this capacitor. Cause the drive in our VBST to receive power. This capacitor is indispensable. It is like a battery here. In a lot of repair, we said that we see the capacitor blown off and fall off. Cause the IC doesn't work, or the operation voltage of the memory is low. This phenomenon is more common. Then this resistor is the same, it is easier to burn. That is to say, after receiving the switch signal, the power supply of the circuit road will also come out. If conditions permit it, we try to use an oscilloscope to measure this pin. It should have a square wave coming out to control the charging and discharging of this capacitor, sent to the pin of VBST through 0 ohm resistor. After receiving this signal, the IC has a square wave to control the conduction of this upper tube. Let the upper tube turn on and charge the inductor. After fully charged, let the lower tube condition inductor and then discharge the memory. After the IC works, it will output a key signal. See power grid 20 pin here. Power grid is called the power grid signal here. Power grid on the mat is default 3.3 volt. That is to say, we're waiting for the 1.2 volt power supply of the large inductor to stabilize after normal. Then this IC outputs a grid signal of 3.3 volt. It means that the circuit work is completed and normal. There is another key point here. Okay, I won't add more analysis in the circuit in the future. There is a VDD voltage here. This memory power supply IC has a voltage stabilizer inside it. It outputs the reference voltage of the memory, which is half of the main power supply of the memory. If the main power supply is 1.5 volt, it is 0.75 volt. If it is 3rd generation memory and 4th generation memory are 1.2 volt, it is a voltage about 0.6 volt depending on how much inductor there is. Look at how much volt is marked on the inductor. This VDD output is equivalent to half of the inductor voltage. Then it says if the main power supply is 1.2 volt, how much is it? 0.6 volt. If the main power supply is 1.5 volt, it will be 0.75 volt. The power supply module inside stabilizer also has a switch signal. Switch signal VDD S3, which is also sent by soft bridge. In other words, these components are most easier to damage in maintenance. If the inductor is measured and there is no voltage in maintenance, then we need to overhaul this circuit. How to fix it? If there is no power supply on the memory after 1.2 volt trigger, but it can be triggered when the screen does not turn on, I first check the value of the inductance to see if it has a short circuit. If there is a short circuit, we will troubleshoot. The short circuit prying open the inductor. Is it the front end short circuit or the back end short circuit to distinguish clearly? If the front end is short circuited, it is usually the lower tube and the main power supply IC that is broken. Test the lower tube first. If the lower tube is not broken, then change the IC. If the back end is short-circuited, the end connected to the capacitor is called back end. Generally, this capacitor should be removed first when the back end is short-circuited. Prevent short circuit caused by the capacitor. If the capacitor is still short-circuited after removing the capacitor, it means that there is a problem inside the CPU. Then why change the CPU? Because the main power supply of our memory, it is not only sent to our memory slot, it will also be sent to a memory controller inside the CPU. So the short circuit of the back end is either caused by the capacitor or caused by the CPU. So how to repair the main power supply of the memory? If there is no short circuit, it still has no voltage. Then we have to measure whether these two tubes are damaged. In the basic closed circuit class, we set the diode tube level, measure the value of D and S. Are there hundreds of ohms? The red multimeter pan was placed at the S pole and the black multimeter pan was placed at the D pole. If there are several hundred, then this tube is good. Both the upper tube and the lower tube has this kind of measurement method. If both the upper tube and the lower tube are good, Remember that this is only done under the condition of connecting circuit to ground. This short circuit has just been mentioned. So here with the MOSFETs intact, you can measure it. Then we replace the memory power supply IC U7300. If it still has same failure after replacing the U7300, at this time we have to open the drawing to check the working conditions of the IC just mentioned, several power supplies, as well as switching signals, VBST and REFIN, whether the basic conditions of them match. Check with peripheral related components, including the 0 ohm resistor at the VBST pin, so it is relatively simple to repair the memory power supply. After triggering, we'll measure its working voltage. Then I will teach you the maintenance method of this internal storage power supply on the whiteboard. Take notes, maybe you may not understand my language clearly. Next, we'll write it in the textbook and notes. Maybe remember to be more thorough. Okay, just through the circuit analysis of how the memory power supply circuit works. Then let's summarize. Our memory power supply if it had no voltage during work. How do we repair it? Let me talk about it here. Memory power supply damage will cause our laptops to trigger a no display. What does it mean that it can be triggered and no display? That is to say, press a switch and the fan is rotating, but the display does not respond to the image. In this case, the first thing we check is the memory power supply. How to repair the memory power supply? We need to check the value of the inductor. One is the value is 0.00, called short circuit. One is value is OL, which is called open circuit. There is also a third type, which has a value, which is called connected circuit. Then the methods of repairing different symptoms are also different. Then we look at the short circuit. To short circuit the front end and to short circuit the back end. Which front end is it? The end close to the MOSFET tube is called front end, and the end close to the current is called back end. Then short circuit of front end is very simple. But this kind of inductor needs to be tied up to measure. After knocking the inductor, then check its value, so it's best to be accurate. This kind of front end short circuit, let's test the lower tube first. The lower tube is the red multimeter pad lead on the S pole and the black multimeter pad lead on the D pole. If the multimeter makes a noise, it means that the lower tube was broken. If there is no sound, then just replace memory power supply IC. The front end short circuit is relatively easy to repair. Then the back end short circuit is relatively troublesome. And the back end short circuit is generally a connected capacitor. Especially for capacitor with polarity, the polarity of failure is higher. If you remove the capacitor and test it, there is no problem. Then just change or reballing the CPU. Why change the CPU? The power supply of the memory is not only sent to the memory, but also to the memory controller inside the CPU memory. As a result, our memory cannot be powered, because it is short circuit. So this part may be more common in the maintenance. So this should also focus on inspection. This kind of part is more common. The second kind is to open circuit to the ground. In the second case, the probability is not great from my years of maintenance experience, but it occasionally appears. In this case, it is either to test the quality of the upper motherboard. Put the red multimeter pad lead on the S pole and the black multimeter pad lead on the D pole. Then the multimeter shows OL. Then just replace it with the tube. If it doesn't work after replacing this upper tube, just replace the IC. Generally speaking, it can be repaired well like this, and the probability is very high. But the odds are not high, just in the maintenance of this phenomenon is not much. The key point is the high probability that the third and first phenomenon may be bad. Then the third type is connected circuit with value. In this case, but if there is no voltage in the connected circuit, it is also bad. On the power supply does not mean that the access must be good. The same is true for other Mac power supplies. Don't think that this connection must be good. Short circuit and open circuit must be bad. When there is no voltage, it may also be a connection. So when we encounter the phenomenon of connecting circuit, first of all, we have to replace the memory power supply IC. There may be a problem in itself. If the memory power supply IC is finished, It is not good. At this time, we immediately open the drawing, open our schematic diagram and big math to correct. When we are repairing MacBook, big maths are also very important because it is relatively small and precise. Open this drawing and check the working conditions of the components connected to these pins of IC. As long as anyone is damaged, the memory power supply IC will not work, causing most to not work, resulting in no voltage on the inductor. So the maintenance of memory power supply is relatively simple. The most vulnerable thing here is the memory power supply IC. And what are the most easily damaged capacitors? One is the IC. The second is the capacitor next to the IC. The third is the upper and lower tube. If you can master these three parts of the detection circuit, 80% of the phones that are repaired for the first time cannot be repaired, even up to 90%. So on the basis of repairing this, everyone must be careful to repair the circuit. This is a principle and maintenance method of the memory power supply we are talking about today. Goodbye.